Hello, so from this video, I will be talking about the design patterns that we can use in machine learning. So these design patterns, this is most widely discussed in software engineering, but we can use them in machine learning as well. Basically, these design patterns, these we cannot use this exact pattern directly to resolve our problems, but we can use them as a template or a description as a help to resolve our problems. So basically, there are three types of design patterns: creational, structural, and behavioral. So in machine learning, the machine learning codes and the development process gets complex and confusing if it does not have any kind of the structure when we when we develop. So using an appropriate design pattern, it will definitely help developers to design new code flexibly, and other users of the code, other future users also can keep the code base clean. This will help to avoid development environments getting complicated. And also, this will make the path for a reusable and maintainable standard code at the end. So I will explain you about few of the design patterns. It's like 7 of them that we can use in machine learning. So let's move on to the first one. So this is the first design pattern I will be explaining to you, and it is factory design pattern. So this comes under creational design patterns. This can be used to create new objects in a better way. So in the factory pattern, we can create a new object by just not exposing without exposing the internal logic or the origin. So the user can use the newly created object through an interface. So I hope you all can see the two lines of code that I have been using here. So I took that from Python code. So in Python we have these type of keywords like init. We can use them to create an object easily. In this pattern, subclasses are responsible for creating instance of the class. And since this uses loose coupling, it eliminates adding application specific classes to the code, so that the code only interacts with the interface, which will provide the advantage to the future users, since this will work with any classes that the interface implements. So that's it about the factory design pattern. And up next we have building design patterns. So this design patterns also falls under creational design patterns. What happens here is basically this is about creating more complex objects in the code. So this also comes under creational design patterns, as I said, and this pattern will separate the construction of a complex object from the representation. So then the same construction process can create different representations, and this will create the final product step by step. Another thing is that this reduces the number of parameters for the constructor. That is also very important and a good thing. In machine learning, building pattern will be helpful, since using blocks which contain a step-by-step procedure. So that is it about building. So under creation as a creational design pattern. So this prototype design pattern will. So this prototype pattern will keeping these two lines of code, that these were also taken from Python code. So in Python they have an object. So using this design pattern changes, since they are independent. So it's like it's basically creating a duplicate object. So this can also be called as cloning an existing object. So you can in Python you can use these two words to. So the next design pattern we have is adapter design pattern. So this comes under structural design patterns. So because of the compatibility of combining two independent interfaces, these types of design patterns comes under structural design patterns. So, so the best real-world example that I can give here is the power plug adapters. Hope you we all might have experienced that if we have square pin chargers, we cannot plug them into circular wall outlet. So we have to use some kind of an adapter if we need to use them. So the exactly same thing happens here. So this adapter, it we can have a single class to combine incompatible functionalities. So we can say that this design pattern as a wrapper which allows incompatible objects to collaborate, and the adapter acts as a wrapper between two objects. It catches calls for one object and it transforms them to format and interface recognizable by the other object, by the second object. So that patterns. So this is actually like a cake. So we have cake and we use icing frosters to decorate our cake. So in decorated design pattern also, we can add new functionality to an existing object easily. There are a few ways that we can do this. Composition, inheritance, and just likewise we have few ways to, and this is also a structural design pattern. So this design pattern creates a decorator class which wraps the original class. It's like the original class is like your cake. We can have a wrapper, we can have a decorator. So the next structural design pattern for machine learning is this facade design pattern. So this is this will help to hide the complexities of the code and provide an interface which is very simplified. So basically this creates an interface to and existing functionality in order to hide its complexities. So while it removing the overall complexity of the application of the code, it also helps to move all unused dependencies into one place. So the final design pattern we have is flyweight design pattern. This also can be used in machine learning, and this also comes under structural design patterns. This pattern is used when there is a need to create a large number of objects of almost similar similar nature. So the large number of objects consume a large amount of memory, obviously. So this flyweight is used to reduce the number of objects created to decrease the memory footprint and increase the performance. So this pattern provides ways to decrease object count, but it also improves the object structure of the application. So this flyweight pattern tries to reduce already existing similar kind of objects. So whenever there is an existing object that is related, that is relevant, that we can use for the purpose that we have. The new object will be only created when we cannot use an existing object. If not, we will be using an existing object that we can use that is relevant for our purpose. So that is it about all these 7 design patterns that we can use in machine learning for better outcomes. Thank you.